Hi, this is the video for the solution to problem 4 on the handout. In particular, what we're going to be doing is creating a parameterized version, not abstract. Remember, we use the word parameterized for this semester. So parameterized. And down here it's parameterized. Given that now we have input sets and parameters for our Farmer Jones. And note that what we're going to actually create is a family of problems. And in order to solve the family, you would need to define what one of all the sets. And I'm going to do that at the end of this too, just so you can see how this would all work. Okay, so what we're given is C is a set of cookie types. R is a set of ingredients used to make any of the cookie types. For J, we get for J and C, we have a profits C sub J of cookie type J, and X sub J denotes the decision variable, representing how much of type J cookies to bake. So that's our decision variable. Then B sub I denotes the total amount of ingredient I, and then Aij is the amount of ingredient I used to make a single cookie of type J. So just to keep it clear here, our parameters in this model they're going to be CJ, BI, and AIJ for I in R and J in C. Our decision variables here are X sub J for J and C. Okay. And they're defined up there, so I'm not going to repeat the definition. I just want to clarify which is which. And of course, our sets here, which you can argue are parameters. I'll just call them sets because they're such a special thing. There's C and R, okay? And these are cookie types and ingredients is R. Okay, so how do we write down this model? Remember, we're trying to maximize our profits. And before we had to write out a whole list of things, but now we can use these parameters and sets to help us. So we want to sum over the cookie types of the profit of a cookie, CJ, times the amount of cookie we make, XJ. And that summation encompasses everything. And it's subject to, well, we have the ingredient limits. All right, this is our resource constraints. And this is that the sum over the cookie types of Aij, Xj, has to be less than or equal to Bi for I in R. Okay. And note how what this does is it repeats this constraint for every ingredient in R. Every ingredient I in R, there's a constraint written. The sum is over the amount of each cookie multiplied by the amount of the ingredient it takes, which is Aij. Finally, we have non-negativity. And again, for every single cookie type, we have, this is a period, we have a non-negativity constraint. Okay. Now, again, this is a parameterized model now. It defines a whole infinite family of different optimization problems. How would we instantiate it? To instantiate it, an instance is just one version of the problem. So let's instantiate. It's a nice word, instantiate. To do that, we have to give real numbers to things. So I'm going to do that. So I'm going to say C equals chocolate and vanilla. R that's going to be equal to flour and eggs. We will have that the profit, C, chocolate. Actually, I'm going to abbreviate that, CH. Well, that'll be equal to, say, $4. And the cost of vanilla, which I'll abbreviate with a V period, equals $3. Okay. We'll have B flour equals 48. B eggs equals 32. A, say, flour, I'll abbreviate that with an F, CH equals 4. A F period V period will equal, say, 4. And AE for eggs and chocolate. I forget how much that was. Let's just say that was 6. And eggs, vanilla. Let's say that was equal to 2. I think that's correct. Anyway, this is basically how we would instantiate this. We would create from this generic problem, this parameterized model. This is how we would create, oh, that's weird and squiggly. This is how we would create the original problem that we had. But note now that we could now make this problem even larger, right? If we expanded this, so that's one instance. If we expanded this and we just said, well, let's suppose there were, 100 different, maybe we numbered them, 100 different cookie types, and they were made from, say, 20 different ingredients, and we'd have to use probably a spreadsheet or something, or a table, a larger data file to define the rest of the parameters. I'm not going to write them down here because that would take too long. You could create as large a problem as you wanted. Okay. And what's cool about this, of course, is that no matter how large the problem you make, the formulation is simply this right here.